Good morning, and thank you for staying around to listen to my speech. I think before I start, I'll set the context. I think if you're looking for pearls of wisdom on AI, I don't think this is the session. I propose maybe you can go and check out, have a sneak preview of the lunch menu which is there. However, if you are taking trains, and if you have ever taken trains in your life, maybe this will be a very interesting session for you because you have traveled in a train. I think definitely it's going to be very interesting for you to know what happens a little bit behind the scenes, especially with AI, which has also invaded very, very traditional business like our train industry. Okay? So let me just quickly start off. Alstom, what have we been doing in India? Alstom has been present in India for more than 100 years, okay? We have been here through this transformation that you see here, right from these kind of trains to these kind of trains. What is Alstom doing in India today? Just to give you a quick preview, I think Alstom, if you look at it, is one of the world leaders when it comes to rail transportation. So all of you are my customers, and it's a pleasure talking to my customers today. I think if you look at it, what Alstom has been, we have close to around 6 factories here which are delivering, not only locomotives but also metros in India and also throughout the world, starting right from Sydney all the way to Montreal. Okay, if you look at it, products are being made in India for these markets. The strongest locomotive for India, which is a 12,000 horsepower locomotive, okay, has been delivered by Alstom. And similarly, if you look at it, the first metro rail system, which is Delhi Line 1, I think it has been delivered by Alstom. And pretty much today, if you look at it, on the signaling side and also, more or less on the rolling stock side, we deliver upwards of 60% plus of the metro systems that are happening in India are from Alstom. Even the fastest train, that is going to run in India in the coming few days, okay, at 160 kilometers per hour, showcasing a world standard in signaling technology, is being delivered by Alstom, and it has been done fully in India. It's going to be inaugurated. It's in trial run. Our Prime Minister should be inaugurating it any time. And not only that, I think since a couple of countries have been in the news for some time, the rail system in Montreal, Canada, has been delivered fully from India. It was inaugurated by Mr. Trudeau. And Israel has been in the news also recently, not for the best of reasons. But why I want to talk about it here is, these metros, right, they run on a technology called communication-based train control. Because there's a lot of communication, there's a lot of cybersecurity in it also. The first cybersecurity-enabled metro has been delivered by Alstom to Tel Aviv Metro. So we sold cybersecurity to the Israelis, done from India. Okay? So this is where we come from. This is a little bit of what we do. And you guys are very lucky, because you're staying here, okay? And I'm not here to sell my company. I think I've sold enough, right? Okay? But however, since all of you have stayed here, with me today, if any of you want to, own a personal locomotive or a train, please contact me. I will give you attractive discounts. Okay? So that being said, I think Alstom has been in the forefront of enabling the sustainable transportation in India, which is the backbone of our transport in India, okay, to world standard levels. Okay, we have been involved in doing this. Okay, more than for the past 100 years, we have been in India, as I told you. A train previously used to be an electrical and a mechanical piece of equipment. Okay? Today it is not. It is an extremely intelligent industrial gadget. Imagine a train drives by itself. Okay? I'm talking about a metro system. A train drives by itself. It will park itself at the at a stabling station, as we call it. Okay, it parks itself. In the morning, it wakes up by itself. It does all its self-tests. Okay, does all its self-tests. And then it starts running by itself for the entire day, and then it comes back again. Interesting, right? Imagine the amount of intelligence. You thought there's a driver that is required to do all these things, right? This kind of system has already been established in India by Alstom. A couple of the Delhi lines, Alstom pretty much, out of the 10 lines that we have in Delhi today, 7 of these lines are run by Alstom, and 2 of them are equipped with this kind of a system that I spoke to you about. Okay? So that is the level of innovation that we are having today in a traditional sector like rail. So what I'm going to speak here today is, how is AI acting as an enabler for us to deliver, not only better products, but also, improve the experience of our customers, both our operators as well as all of you, the society. So we are an extremely safety-driven industry. We're an extremely safety-driven industry, okay? Because most of our software, if you look at it, it is safety integrity level 4, the highest level of safety that you can have. So that being said, whenever I'm trying to harness a new way of working, a new technology, I need to ensure that the functional safety is taken care of so that all of you can be safe. So I just want to talk about the relationship of safety with AI to start with. Then I will talk about, some use cases as to how AI is influencing, our rail industry. Okay, especially in the aspects of safety, of course, how it is improving the customer experience, okay, both operators and passengers. And then I will also talk about, how it has revolutionized predictive and, conditional monitoring, maintenance and monitoring. Okay, last but not the least, I'll also touch upon autonomous trains, okay, which can soon become a reality. Okay, so here if you look at it, what I'm trying to say is, I'm trying to compare, how the levels of AI interact with the functional safety elements which are there. Okay, now we have different levels of AI which is there, starting right from, diagnosis, control, okay, then, development, validation, if you look at it, and we are also talking about, things where, we don't really have a safety relevance. But what we are trying to always compare when we are working on rail-related systems is, we want to see whether the risk is accessible or not. That is the main thing for us. Okay? So if you look at it in a class 1, if you look at it, okay, we are able to assess it pretty well. Okay, we already know what's going on. Class 2, if you look at it, there is a possibility to assess, but it's not known. And then, of course, where, it is not possible to assess at all. So rail industry today, if you look at it, we are more working on the class 1 and class 2 only today. Okay, and of course, the bottom line which is there, level D, of course, we can always use. Next, talking about, the different levels of AI which are there. Okay, and how, if you look at it, which are the areas that could be useful for a industry like rail. Okay? So if you look at it, there is a level 1, which is basically assistance to humans. This definitely, we are doing. If you look at it, these chatbots and all that which people spoke, I think that is also pretty much prevalent in the rail industry today also. If you look at it, there is a chatbot called Indra. If you look at it in IRCTC, okay, if you get to use the IRCTC sites, I think you can experience a chatbot called Indra, okay, which is more based on AI also. And of course, if you look at human-machine teaming, definitely that is also one area that we can work on. Level 3 autonomous. So I will be covering level 2 majorly today. Okay, and level 3, if you look at it, autonomous machines. There are 2 levels. If you look at it, there's 3A and 3B, which is there. Basically, there is one which is a AI-based system, but where decisions can be overridden by humans. So this is something which is happening in our industry today. But whereas the last one, the 3B element, is something which we are not able to access at this point of time, okay, because of safety reasons. Okay? Please bear in mind, anything that we do, it has to be driven by safety for us. Okay? So, when I'm talking, as I told you, when I'm talking about how AI is shaping the future of mobility, I think if you look at the first element I'll touch upon is basically safety and security, because that is the most important thing. Because my industry is driven, the rail industry is driven by a few parameters. Okay, safety, reliability, availability, and efficiency. Okay, these are the 4 factors which are driving rail industry today. And those are the elements that I'm going to cover today. And of course, a little bit more sexier one is the autonomous trains, because all of us are seeing autonomous cars these days, right? So let us see how we can have autonomous trains and how we can, buy one for our personal use, okay? Super. I was speaking to you about 12,000 horsepower locomotive, which is the most highest powered locomotive in India, right? That's the one. We call it fondly in our company as the blue elephant. Okay? So what am I trying to say here? How AI is being used for obstacle detection on tracks so that we can improve the safety of the system. And of course, it also helps us in maintainability also. Many of us, we have seen in pictures, right? Okay, heroine will come and wave this dupatta and the train stops immediately. In real life, it's slightly different. Okay, TGV is one of our trains. Okay, it has created the world record of 574 kilometers speed on tracks. Okay, average speed is around 300 kilometers or so. For this train to come to a stop from the time you hit a brake, it is 3.2 kilometers. Okay, a car can stop in a few meters. 3.2 kilometers it will take. Imagine a train in India where it's running at roughly around 100 kilometers per hour. It will take you at least a kilometer to stop. So you jump in front, very much in front, you are in trouble. Okay? Here what we are trying to do is, if you look at it, this is something which we have done in Alstom, where what we are doing is, we are having cameras, we are having AI-enabled cameras mounted on a train, okay, with which we are able to get visibility of the data on the tracks. Okay, if you look at it, there are different types of cameras that can be used. Okay, you can use regular cameras, but today, if you look at it, there are cameras, which are infrared cameras. You have night vision cameras, you have thermal sensing cameras. Okay, with which we are able to also ascertain whether it is an inanimate object or it's something, it's an animate thing that is on the track. Okay, based on this, with the support of AI algorithms, what we are able to do is we are able to take decisions on time, so that we can stop the train if possible, okay, before a safety incident happens. So this is something which we are doing. So this is one for safety. Definitely, we also have a use case for this for maintainability also, because we are able to kind of get the entire situation of the track, because rather than send a person to take a look at what's going on in places where there's a flood or something like that, when a train has already gone through, with the imaging that is received from this train, what we are able to do is we are able to promptly predict whether whether this system can be used further or whether there is some maintenance activity to be taken without actually sending anybody there. Okay, and all these are driven by AI algorithms today. The next element that I want to touch upon is, I was talking to you about customer experience. I will take the operator's perspective because they are the ones who pay us actually, okay? So that's my first preference, okay? And so if you look at it pretty much, the data sources, we have the existing data sources today. And definitely if you look at it, we have our big data and, machine learning, which gives operators, we are able to get the right visibility on the passenger flow. Today, if you look at it, we are able to anticipate passenger, density to an extent that, okay, at this time, if there is going to be rain and, if there's going to be a festival, all things put together, what will be the intensity of traffic or saturation of traffic that I'm going to see, I am able to predict. Okay, that is the level of prediction that the operators are able to do. And, definitely, for demand management, fantastic use of AI is being made today in our industry, okay? And, because, we are able to use these kind of things, if you look at it, we are able to also operate the system much more efficiently. At what time we have to run more trains, at when we know you should run lesser. So I think this demand forecasting, it has worked fantastically, in terms of, in terms of predictability, for our operators. The next element is, of course, all of you, passengers. Okay, we have similar data sources. Of course, we are also having now surveillance cameras and mobile networks and all that, okay, along with what we have over here. And similarly, same using big data and your ML, we are able to provide you very reliable information today, okay? And just imagine, okay, there's a small thing that I have given here, okay? What happens is, a lot of times, we have gone to a metro station. Let's take there is an 8-car metro which is there. Just because, the steps were very close by, we would have gotten at this point or we would have gotten at this point. And then the train comes, it comes full, whatever compartments you're staying near is pretty full. And what happens is you don't board the train because you're unable to board the train. But when the train passes by, you will see that in between there were so many compartments which were empty. But today, with the predictive analysis algorithms that we are having, which operators are able to, put in, we are able to also give customers information, okay, worldwide, in some systems where we are able to tell them what exactly, is the kind of, which compartment maybe is relatively empty and, you can go and stand there. So all this is being enabled because of AI. And one of the major things that has happened today is our multimodal, transport, which is there, okay? Where we are able to kind of, interact rail systems with the overall network and give the best experience and suggestions for our customers. So Mastria is a product of Alstom, which is a multimodal transport solution, okay, which basically helps to handle, crowd saturations, whatever is there, okay? So we are able to predict the passenger flow demands, with the data that we are having. If you look at it, we have the ticketing data, we have the signaling data, and then, we are able to say exactly, okay, fine, if the train is really crazy, okay, how is it that we can ask people to, access to other parts, other types of transport? The train is down, how can we manage the network, the entire network? Not just the train, the entire city transportation network for people to ensure that, they can go to their destination. Doing like this, we have been able to, the fail to board ratio, we have dropped by about 40%. This is a use case that we have from our Panama Metro, okay? All these things might look a bit simple, but, it has a lot of effect on all our day-to-day lives. I'm just waiting for the time that we get to implement these kind of solutions in India also, okay? And this is one area where if you look at it, I think AI is being used, in a maximum way, okay? Predictive maintenance to improve operational efficiency. Okay, today, if you look at it, as I mentioned to you, the train is an electronic gadget. There is so many remote sensors which are there. Combined with our computing methods, our IoT and our big analytics and all that. Okay, we are definitely, if you look at it, we are able to reduce the costs in a significant way. Some of our operators have told that, with this predictive maintainability that we are having, they are able to cut down maintenance costs by 50%. And imagine, it's not small amounts. So I'm talking about, millions running into billions, actually. Train networks, okay, maintaining a train network, okay? And definitely, I think if you look at it, asset availability also, if you look at it, because if you're able to predict failures, see, for us, if you look at it, when we design a system, we need to design a system for 99.9% availability. Will you be happy, if out of a week, 2 days, the train is not there? So for that kind of availability, definitely if you look at our predictive and preventive maintenance, AI-driven algorithms are definitely, helping the world. Of course, we are having some challenges also, okay, because, if you look at it, we need to, this is a more traditional industry. It is now that we have started, getting more data, from our trains with a lot of electronics and all that. So definitely, I think if you look at it, I think we are on the right path. But at the same time, if you look at it, there are also compliance, regulatory requirements which are there. As I told you, we are a very safety-driven industry. We are answerable not only to the people, but we are also answerable to the authorities. So whenever we are integrating these kind of things, okay, we need to do it, in a more, a thought-about way. Okay? So I told you, just to give you an example, okay, so these are some of the benefits of predictive maintenance. Just to give you an example, okay, when you're talking about availability, reliability, and all that, in India, we have developed a solution. If you look at it, every train system, if you look at it, it is basically the train communicating with something on the tracks, okay, so that, we are able to, maintain this train on the system, okay? If a communication loss happens, what can happen is, you'll really be in trouble. If a communication situation happens, okay, then what happens, immediately the train will stop, because safety. If the train is not visible, to the control center, it will stop. So what we have done is, we have created an AI-based tool we have created for monitoring the performance of the radio. Okay, for the radios, which are transmitting between the train and track. What we do is, anytime, there is going to be, if we see that the working capacity of a radio is not in the line, is not along the expected lines, we are immediately able to take action so that, we are not kind of having this failure, during the time of the train running. This is something which we have done. So as I told you, if you look at it, asset health, of course, I spoke about asset health. Manpower also, if you look at it, because for AMC, we don't have, every week you just don't have to keep sending people. You can send people only when required for what it is required, okay, based on your predictability analysis that you have, powered by AI, okay? And of course, definitely, will have much more control on your spare parts inventory. I don't want to teach train to you, but basically, this is how our world operates. If you look at it, this GOA is basically grades of automation. Okay? And if you look at it, in India, we have implemented this second grade of automation, which is there, because that was our earlier technology. And today, if you look at it, basically, we are operating on the last two. Any metros that we are doing today. In fact, in India, I think out of, I don't know, maybe about 30 lines, I think Alstom would be operating close to about, upwards of 20 plus lines is being operated by Alstom today. Okay? So both these levels of automation are there. But the thing is, this is not autonomous trains. This is about automatic trains, okay? I will tell you why. There is a subtle difference between automatic trains and autonomous trains. Automatic trains are like metros, as I told you, they do their thing, they wake up in the morning, they go do their work, they can go wash themselves, so all these things can happen. But however, when it comes, but if you look at it, this operates, if you look at it, segregated tracks, a closed system, where, where it is the situations are pretty predictable. Okay? So the system thinks for the train. The system sees things and decides for the train. But whereas when it comes to an autonomous train, you want the train to basically, see, think, and decide. Okay? So this is what basically, we are trying to go towards. And one of the main elements that is going to be used on this for your autonomous trains is basically your obstacle detection, okay, your ODS system. That is what is basically required. The other three systems are already there, which helps you, go to the highest levels of automation in automatic trains. Okay? Benefits, of course, there's a lot of benefits that is here, increased capacity, we can have better capacity, we can have much less, energy costs in terms of workings. All these things can happen, Okay, so what we are doing is, we have done some experiments in terms of autonomous trains, okay. So we have demonstrated it today. So if you look at it, today, the train is able to, understand the color of the signal, of course, okay? But then we are also enabling the train with a computer vision. That is what we have done. And with this, what we have done is, we have been able to also integrate, this obstacle detection. We have done it, on this case, we have done it through a radar-based obstacle detection system. So, and then we have done a trials also, okay? This is the first trials of autonomous trains that we have done, where a train, you have seen the shunting of the train, right? Okay, one train comes and, they couple together, right? That we have been able to do it in an automatic way, in an uncontrolled environment, okay? Not in a controlled environment, but in an uncontrolled environment. So I just want to quickly share a video on this, and with this, I will end my presentation here and take questions, okay? Over to the video. Thank you. I think definitely, this is going to be one of the forerunners in terms of technology for us towards autonomous trains, okay? So we have done a few demonstrations. There has been some progress, okay, on these lines, okay? And definitely we look forward to, bringing these kind of technologies to India. Definitely, strongly enabled by AI. I think there's a lot of activity going on. Today, if you look at it, there's a technology shift in our industry, from what we have been doing traditionally to the new age technologies, okay, going into cloud, going into AI, going into, different other aspects, which are there, okay? And I want to say that, more than 40% of Alstom's R&D, global R&D, is done from India today, where the shift of our products from what technology we are to the new age technologies is happening in India right now as we speak. Okay? So thank you. Thank you for your patient listening.
Thank you for that. We have time for one question. So in case someone has a question, yes, the gentleman up front, please go ahead.
So in our industry also, we are doing predictive maintenance. And I have seen in Alstom also, you are doing predictive maintenance projects. So my question is, unplanned downtime we can reduce, and maybe we can increase the customer satisfaction. But my question is how Alstom is gaining monetary value with the predictive maintenance algorithm, whatever you will be putting. Benefit to customers, that is I understand, we can improve the uptime. So are we charging extra for maintaining the uptime to the customer end?
Okay. See, these days, if you look at it, right, okay, predictive maintainability is a spec that comes on a tender itself, okay? So, it might not be a direct, revenue generation for Alstom. But usually, who are we selling it? We are selling it to the operators, who are our customers. And definitely, they want a system which is more efficient, which is less maintainable. Okay, so this is a benefit which the customer pays Alstom for providing, but the actual benefit will be reaped by the customer only, by the operators. Okay, it's not a money-making machine for Alstom, but it's more an enabler for the customer to run efficient operations.
Okay. My next question is whatever you are saying, you are putting the camera for object detection, but suppose the train is going at 100 km/h speed, and there is a turn is coming, and after turning immediately there is some obstacle, some has removed the track, and whatever recently happened in the Odisha, that. So such type of incidents, how you can avoid? Are you putting some vibration sensor in the train or noise sensor along with the vision camera?
See, I think what happened in Balasore is more under this one, but I don't think, there was any obstacle or whatever at this point of time, what is being mentioned today. See, if you decide to come and jump in front of the train at 5 meters, I think, Alstom can only meet you in heaven, okay? That's why I was telling you, basically, at least, if you look at it, the camera visibility we are having, if you're having it to a kilometer these days, okay, we are able to sense till a kilometer. Definitely, today the average speed at which the trains are running in India is roughly between, to 80 kilometers per hour. That is average speed, okay, even if you take your Vande Bharat or whatever, average speed is 80. The one that we are coming up with basically is going to run, design speed is 160. I've been in the train which is running at 160, but today, the operational speed will be anywhere between 120. That's what it's going to be. Okay. So for that, if you look at it, if I have a 1 kilometer visibility, I think it's a good starting point, in terms of detecting an obstacle and taking some measure to stop.
Okay,
Thank you for that, sir. It seems like you have a lot of people who want to ask you a lot of questions. May I request you to take the conversation outside and answer some of those questions?
Of course, it will be my pleasure.
Okay. Thank you very much.
Thank you. Thanks a lot for listening. Pleasure talking to all of you. Thank you.